Today's lesson is on solving compound inequalities. So we'll start with first a refresher on solving and graphing inequalities. So we have 3x plus 7 is greater than 22. We'll start by subtracting 7. And when we do that, we have 3x is greater than 15. And then we divide by 3. And we have x is greater than 5. Remember that the inequality is like an arrow and it tells you which way to graph or shade your graph as long as the variable is on the left side. And because this has a greater than, remember that greater thans or less thans get an open circle, and a greater than or equal to or a less than or equal to get a closed circle. So this will have an open circle. I'm just going to put a 5 here. Oops, that's not a negative 5. Put a 5 here, and to the left of that is 0, and then we will shade to the right with an open circle on 5. The next one, we'll first take care of getting rid of the parentheses. If you remember your foldable, it says if there are grouping symbols, parentheses, then we'll take care of that by distribution. So we'll distribute. And we'll have 9w plus 3 is greater than or equal to 48. We'll subtract 3. And we'll get 9w is greater than or equal to 45. And then we'll divide by 9. And we'll have w is greater than or equal to 5. And then that gets a closed circle, because it has the equals to, and it will shade also to the right. So solving compound inequalities, you have ands. Ands will cover the area that makes statement both true. So it's the commonly covered area, the commonly shaded area between two inequalities. Here's an example here. It says write a compound inequality or it has a word containing and it's both true. So you have x is greater than or equal to negative 4. So that shades to the right. And then it says x is less than 3. That shades to the left. But the only region that they have in common is this region here in between negative 4 and positive 3. We won't include this area because that's not common to the left of negative 4, and it's not common to the right of 3. It's only that commonly shaded area. That's that intersection part of the inequality. So here is a compound inequality written as one whole statement. You can solve these separately. If you solve them separately, you'll take what is to the left of the inequality and the center, and you will write it separately here. And then you'll do the same thing with the center and the right side of the inequality and write that statement. And then you'll solve them separately. So here we will add 2. And we have 12 is less than or equal to 3x, and then divide by 3. So we have 4 is less than or equal to x. Now, if I was going to rely on this to help me with my shading, I need to flip this inequality and mirror it so that the x is on the left side so that I understand which direction that I would be shading. So this would be x is greater than or equal to 4. I'm going to solve the second part of that by adding 2. So we have 3x is less than 21. Divide by 3. And we have x is less than 7. Okay? So you can see where you have a 4, you have 7. The 4 gets a closed circle. The 7 gets an open circle. So if I'm going to, let me change the color on that 7. We'll change it to red. Okay, so if I'm going to shade in here, it says to the right of 4. So this direction is to the right of 4. And it says to the left of 7. So here is to the left of 7. So the common area that we would be shading is right here in the middle only. That's the place where the two overlap each other. So ands always join together. So you would shade towards each other and don't go past the two numbers. Here you can see it a little bit better if you solve it just both together. So you have your inequality, or sorry, you have your expression 3x minus 2 in the center. So you can work both sides at the same time. If I add 2 to clear the 2 out from the center, then I'm going to add 2 to the ends. Clears out of the center, gives me a 12 is less than or equal to 3x is less than 21. So you can see there's that 12 and there's the 21 from the first method that I used. And then we will divide by 3 to everything to clear out the 3 from the center, and you will see 4 is less than or equal to x is less than 7. So you can see x is right in between. These have less thans. So if there is if it's less than and x is in the middle, then it shades in between 4 and 7. Closed on 4, open on 7. All right, here's another one. I'm going to solve using the second method, but if you like to pause and work it out on your own just to see if you can work it, if you want to do the first method rather than the second method, then feel free to do that and then see if we can get the same answer. So we have subtract 5 to clear out the 5, so I'll subtract 5 from both the left and the right of the inequality. Then we have 6 is less than or equal to 2x is less than 12. And then we'll divide by 2 everywhere. So I'm going to move my answer over here. So we have 3 is less than or equal to x is less than 6. We have 3 and 6. Oops, not 6 on the number line. 6. There we go. And we have a open circle on the 6 and a closed circle on the 3, and x is in between 3 and 6, so our solutions are in between 3 and 6, which is right here. So that is an and shades in between the two solutions. All right, we are going to solve now an or compound inequality. Is that it doesn't matter if they are both the same or not. A compound inequality contains the word or and is true if one or more of the inequalities is true. So basically it's everything, whether they have something in common or not. So here it has an example of a solution that was x is greater than or equal to 5, so we shade to the right of 5, and then x is less than negative 3, so it shades to the left of negative 3. So our solution, it doesn't matter that they have a common region. Our solution is going to be the two areas that are joined by the two inequalities, the x is greater than or equal to 5 and x is less than negative 3. So here we have, and commonly you'll see the word or separating these. It won't generally be a compound statement like the previous one. So here it says solve. So we have subtract 3. So we have x is less than negative 1. Or here we're going to divide by a negative 1. And remember, dividing by a negative right here will flip our inequality. So x will change from less than to greater than or equal to positive 4. So on our number line, we have a negative 1 and a positive 4. The negative 1 gets an open circle. The positive 4 gets a closed circle. And then we shade to the left, you can see left of -1. And you can see this is shading to the right of +4. So there is an OR. Here's another one where we will subtract 5. So we have x is less than -4. Divide by -2. Remember that inequality flips, so it changes from a less than to a greater than or equal to 3. So here's our -4 and our +3, and we'll get an open on -4 and a closed on +3. And again, our arrows tell us which direction that we would shade. So we're shading to the left of -4 and to the right of +3. And that is your compound inequality using OR. Here's a problem that you can work through. Bring your answer back with you to when you come back to class, and we will discuss your answer in the morning.